Nobody has ever crossed a single light year. Not a person, not a probe, not one machine we have ever built. Voyager 1 left Earth in 1977. It has been falling outward ever since. 49 years, no stops, no breaks, and it still has not traveled one light day, one day of light, after a lifetime of flight. The distance we are talking about is almost 6 trillion miles. Say that out loud, and it means nothing. Your brain hears a big number and throws it away. So let me make it worse. At Voyager speed, 1 light year takes about 17,000 years. That is the gap between the first paintings on a cave wall and this sentence. All of recorded history, over and over, just to cross one line. And here is the part that ruins people. When you finally cross that line, you still would not have left the sun. That is not a mistake in the math. Stay with me, because the reason sits at the very edge of everything you were taught about where our solar system ends. Start with the lie you learned in school. Most people think the solar system stops at Pluto. It doesn't. Pluto isn't the fence. Pluto is a rock in the middle of the front yard. The sun's real territory reaches out about 120 times farther than Earth's orbit, to the place where the solar wind finally slams into the gas between the stars. That is the doorstep, not the door. Getting even that far is brutal. To leave Earth at all, a rocket has to hit about 25,000 miles an hour, faster than a rifle bullet. We call it escape velocity, and it sounds like freedom. It isn't. It only gets you off the porch, because the sun does not let go. It pulls on everything nearby, and it never stops pulling. The Voyager probes needed decades just to get past the outer planets, and the sun was dragging on them the entire time. Every mile was uphill. Voyager 1 is now about 15 billion miles out, in light that is 23 hours away. Around 2029, it finally crosses 1 full light day, and Mission Control will mark it as a milestone. 1 day out of 365. So picture the ride. You are aboard. There is no window rush, no engine roar, no pressure in your chest. Without acceleration, moving through space feels exactly like sitting still. You could not tell 300 miles an hour from 300,000. Outside, nothing moves. No planets sliding past, no landscape. The same stars in the same places, month after month, year after year. The space you are crossing is emptier than any vacuum we can build on Earth. A box out there the size of your bedroom holds fewer atoms than a single grain of sand. You are not traveling through space, you are traveling through absence. And behind you, the porch light goes out. The sun does not vanish all at once, it just dims. Month by month it shrinks, until it is one dot among thousands. And one day you look back and cannot pick out which dot used to be home. Now try to call someone about it. From the edge of the solar system, a radio message already takes hours. At 1 light year, it takes a full year to arrive, by definition, and another year for the answer. Ask a question at 20. Hear the reply at 22. There is no such thing as a conversation out there, so how fast can we actually go? There are only 3 honest answers. The first is Voyager. 38,000 miles an hour, the fastest thing we have ever thrown out of the solar system. 1 light year, 17,000 years. The second is the Parker Solar Probe. Diving through the sun's outer atmosphere, it hit about 430,000 miles an hour, the fastest any human object has ever moved. That record cuts the number by more than 10. 1 light year drops to roughly 1,500 years. 1,500 years at the absolute limit of everything we have ever built. Launch it the year Rome fell, and it would still be short of the finish line. The third answer is not real yet. Breakthrough Starshot wants to fire lasers at tiny sails and push them to 1/5 the speed of light. At that speed, 1 light year takes about 5 years. Finally, a human-sized number. Then you read the fine print. The probe weighs a few grams. It is the size of a postage stamp. No crew, no water, no food, no way to slow down at the other end. Add mass and the whole thing collapses. Add life support, shielding, fuel to brake, and the speed falls back to a fraction of a fraction. Chemical rockets can't do it. Ion engines are efficient, but they take years to build up any real speed at all. And the faster you go, the more the emptiness starts to bite. Out there, no magnetic field is protecting you. Cosmic radiation cuts through living tissue year after year, and nobody has built shielding that holds up for decades. Then there is dust. A single speck, smaller than a grain of sand, becomes a bullet at those speeds. 1 grain, 1 hole, 1 dead ship, halfway through a trip that nobody on Earth will live to hear about. So say you survive all of it. Say you cross the full light year. Here is what waits. Beyond the sun's doorstep lies the Oort cloud, a shell of frozen debris wrapped around our entire solar system. Its outer edge is estimated at roughly 1 light year out. Some estimates push it to 2. Read that again. You could fly 6 trillion miles, spend 17,000 years or 400, buried generations in the dark, and still be inside your own solar system, still circling the same star, still in the yard. The first light year isn't a trip between stars. It is us finally reaching our own fence, and nobody knows exactly where that fence is. We have never seen the Oort cloud directly. It is too dark, too spread out, too cold. We know it from the comets it throws at us, like hearing something move in a room with the lights off. Now look at the scale that was waiting the whole time. Proxima Centauri, the closest star to the Sun, sits 4.2 light-years away. After that entire nightmare of a crossing, you would not be a quarter of the way there, and Proxima is the easy one. Most stars you can see tonight are 10, 50, 100 light-years out. Our galaxy is more than 100,000 light-years wide. Everyone says the universe is big. That word does nothing. This is what big actually means. The first and smallest step, the one that doesn't even get us off our own property, is already past the reach of every engine, every material, every human lifespan we have. We are not explorers yet. We are still standing in the yard, looking up at the fence.